Welcome to lesson 6.1 on isolating y, tables of values, and plotting lines. We're also going to go into some of the beginnings of definitions for linear equations. Question 1 asks us to isolate y in the following equations. And just a reminder that isolate y means to get y by itself. So in 1a, we've got y minus 2x equals 0. I'm going to take the minus 2x, bring it to the other side, because we want y by itself. So we would get y equals positive 2x, and y is isolated. Question B, we want y by itself. So I'm going to take that 3x that was positive, bring it to the other side, and we'll get y equals 0 minus 3x. Or y just equals minus 3x. Question C, we want y by itself. That means we're going to take the minus x and the plus 2, both of those, and bring them to the other side. So we'll get y equals, subtracting x turns into adding x, positive 2 turns into, adding 2 turns into subtracting 2. So y equals an x minus 2. This one, for D, we're going to bring the x over, which gives 5y equals 25 minus x. And then I'm going to divide everything by 5. So we get y equals 5 minus x over 5. For E, we want y by itself. So the first thing I'm going to do is bring this and that over to the other side. So 2y equals minus 6x turns into positive, and adding 8 turns into subtracting 8. We want y by itself, and it's being multiplied by 2, so we're going to divide every single part by 2, and we get y equals 3x minus 4. For F, we're going to leave the minus 3y there. X becomes negative x, negative 6 becomes positive 6. We want y absolutely by itself, so divide everything by minus 3. So we get y equals positive x over 3, plus 6 divided by minus 3 gives me minus 2. So that's our answer for that one. For G, 5y stays on this side, equals positive 3x turns to negative 3x, minus 7 to plus 7. Divide every single bit by 5. So we get y equals minus 3 over 5x plus 7 over 5. Question H. 4y stays on the left. Positive 3x becomes minus 3x plus 16 becomes minus 16. Divide every single thing by 4. And we get y equals minus 3 over 4x minus 4. For the next one, using the following linear relations, fill in the table of values. So they've given us a bunch of x's, and we're going to take those x values, substitute them in, and figure out what y is. So for the top one, y would equal, up here we had 2, so it's going to be 2 times, and now our x is minus 2 plus 3. So that would be minus 4 plus 3, which is minus 1. So that would be the first one. I'm just going to change colors so it's easier to see. So here y equals 2 again, but now x is minus 1 plus 3. So that gives minus 2 plus 3, which gives me positive 1. Next one, 2 times 0 plus 3, which gives me 0 plus 3, which gives 3. And I'm starting to see a pattern. I'm starting to see that each time I do something, it's going up by 1, but I'll still go try the next one. Y equals 2 times positive 1 plus 3 equals 2 plus 3, which is 5. Y equals 2 times 2 plus 3, which is 4, plus 3, which is 7. That's question A. Question B, for our x's, this time they're not going up by 1s. And if we look at the question, in this question we have x divided by something, and I'm just going to write a note. If we have x divided by something, we want to choose we just want to choose our x values in the table that can be divided nicely, like with no remainder, nicely by that something. So in this case, the denominator was 3. So all the x values were chosen that they are nice numbers when we're dividing by 3. So minus 6 will give us, well, let's just do it. For the first one, y equals minus 6 divided by 3 minus 4. So that's minus 2 minus 4, which gives a final answer of minus 6. The second one would be, now x is minus 3 divided by 3 minus 4, or minus 1 minus 4, which is minus 5. Next would be y is 0 divided by 3 minus 4, which is 0 minus 4, which is minus 4. Y equals 3 divided by 3 minus 4, or 1 minus 4, which is minus 3. And for the last one, y equals 6 divided by 3 minus 4, which is 2 minus 4, or minus 2. For question C, this time they've written it, but y isn't by itself. So it's 5x minus y equals 0. But they gave us a hint to isolate y first. So we're going to take this, 5x minus y equals 4. We want y by itself. Sometimes it's faster to just, if you have a minus y, I'm going to move the y over and it'll become a positive. And then I'll take the 4 and move it back, and the 4 will become a negative. So we would get 5x minus 4 equals y. And we've isolated y just kind of backwards from before. And if we use that now, substituting in our x, let's use a different color, in our x, for our x over here, we get y equals 5 times minus 2 minus 4, which is minus 10 minus 4, which is minus 14. For the second one, we'd have y equals 5 times minus 1 minus 4, which is minus 5 minus 4, or minus 9. Y equals 5 times 0. This stuff isn't hard. It's just kind of boring. But pretty soon we're going to be graphing the stuff, so it makes it a little more worthwhile. Next one, 5 times 1 minus 4. So that's 5 minus 4, which is positive 1. And last but not least, well, I'm going to show you a trick right now. If we were to do this, do you notice that each time we're going up by 5? Minus 14 to minus 9, we went up by 5 and then up by 5 and up by 5 again. So if we followed the pattern, we could see that we could predict that it's going to be 6. And then if we check, y equals 5 times 2 minus 4, that's 10 minus 4, that equals 6. So in linear equations, if you can figure out what the pattern is, that can sometimes save you a lot of time. D, we're going to isolate y again. So we're going to take this over here to y plus x equals 10. And that give me 2y equals minus x plus 10. Or y equals minus x over 2 plus 10 over 2, which is y equals minus x over 2 plus 5. So that's going to be our equation that we're going to substitute our x values into x. So we get y equals minus x. So that's minus minus 4 over 2 plus 5. So that's going to give me plus 4 divided by 2, because minus minus is a plus. 4 divided by 2 is 2 plus 5. So that gives 7. And you may have noticed that the x's here are air quote nice numbers. when we're dividing by 2. So they're all even numbers, which is easy. Makes it easier, no decimals. For the second one, I'm going to minus 2 over 2 plus 5. So that gives plus 1 plus 5, which is 6. Y equals minus 0 over 2, which is just 0. Plus 5, final answer of 5. And if you notice the pattern, each time we're going down by 1. So I would predict that our next two are 4 and 3, but I'll just do it really quickly. So 2 over 2 plus 5. Oh, minus 2 over 2, because it's subtracting. So that's minus 1 plus 5, which is 4. And then y equals minus 4 over 2 plus 5, which is minus 2 plus 5, which is 3. Okay, finally, in the next one, we're going to actually start graphing. So we have y equals 2x, and this time it's blank. We're going to have to fill in our own x's, but that's okay, minus 3. So I'm going to start with just some pretty basic ones. I'm going to do minus 4, minus 2, 0, 2, 4. You could have done minus 2, minus 1, 0. It doesn't really matter. We don't have to worry about dividing. I just did this because graphing it's going to be a little bit easier. So for the first one, we'd get y equals 2 times minus 4 minus 3. And that would give us minus 8 minus 3, which is minus 11. So this right here is the point minus 4, comma, minus 11. And if we were going to graph that point, minus 4 on the x-axis means we'd go 4 this way. And then minus 11 means we're going to go down all the way to like right here. I'm going to erase all of that stuff though and just put our dot that is left 4 and down 11, and that's our first point. For the second one, y equals 2 times minus 2 minus 3. So minus 4 minus 3 gives us minus 7. And if I graph this, when I go to minus 2 on the x-axis and then down to minus 7, so that's going to be my point. For when it's 0, y equals 2 times 0 minus 3, we get 0 minus 3, which is just minus 3. And the coordinate 0 means I don't move left or right, but I do go down to minus 3. Next, y equals 2 times 2 minus 3, which is 4 minus 3, or 1. And we'll graph the point 2, comma 1. I go across 2 and up 1. Last but not least, y equals 2 times 4 minus 3, which is 8 minus 3, which is 5. And I graph the point right 4 and up 5. And now we're going to connect the dots and draw a line. And when we do this, we get a straight line through all our points. And then the final thing we're going to do here is we're going to write the equation of the line. It's like giving the line a name. We write the equation of the line beside it. Also, please notice that I put arrows at the end of the line because this line goes on forever. It's just those were the points we happened to do. And while we're here, I'm going to take a moment and remind you that this is quadrant 1, and we use Roman numerals. This one here is quadrant 2 with Roman numerals. This quadrant is quadrant 3 and quadrant 4, or IV. And I guess I should have emphasized that y goes to the sky. It's our vertical axis, and x is our horizontal axis. In question B, we're going to do one more graphing. In this one, y isn't by itself, so the first thing we're going to have to do is isolate y. And when we do this, we'll get 4y equals minus 2x plus 12. If we divide everything by 4, we'll get y equals minus 2 over 4x plus 3, or y equals minus 1/2 x plus 3. or x over 2, however you want to think about it. So since we're dividing by 2, we're going to pick, quote, nice numbers for the x's, something, all even numbers that could be divided by 2. So I'm going to pick -4, -2, 0, 2, 4. And when we do this, for the first one, I'm going to just zoom in while we do the calculations. This is like -1 over 2 is the same as -0.5. So y equals -0.5 times -4 plus 3. That's going to give me +2 plus 3, which is 5. For the next one, y equals -0.5 times -2 plus 3, which gives me +1 plus 3, which is 4. Y equals -0.5 times 0, so nothing, plus 3 is just going to be 3. Y equals -0.5 times 2, that's going to give me -1, plus 3 gives an end number of 2. And I hope you can see the pattern here. We're going down by 1 each time. So we don't even have to fill in the last one to know that it's going to be 1. So now we have our 4 points, and we'll graph those. Our first one is -4, so we go left 4 and up 5. So that's our first point. -2, 4 is left 2 and up 4. 0, 3, 2, 2, 4, 1. And I'm going to connect the dots with a straight line. So you should use a ruler or a straight edge if you can. We're going to draw the arrows at the ends. And I'm going to write the equation of the line beside it. So 4y plus 2x equals 12. And we've drawn our line. This one here, skip ahead if you feel like you've got it now. First thing I'm going to do is isolate y. So this would be y equals -x minus 5. Don't have to be fancy or careful with our x's. So I'm going to just pick different ones this time. -2, 0, 2, 4, 6. Because it doesn't really matter what you pick. So here y would equal -2 minus 5, which is 2 minus 5 or -3. Here we get -0 minus 5, which is just -5. When y is 2, we'll have -2 minus 5, which is -7. When y is 4, we get -4 minus 5, which is -9. And then we get -6 minus 5, which is -11. So if we graph these, the first one is -2 minus 3. So I go across 2 and down 3. My point is right here. The second one for 0 minus 5 means I don't move up and down, but I go down to -5. And then 2 minus 7, 4 minus 9. And we've got more than enough dots. We could draw the next one. It's going to be sort of right here. But you really only need 2 of them to draw the line, and then 3 will help you make sure. And if you do 4 more, then you'll really, really be sure. So I draw the arrows on the end. Don't forget the arrows on the end. And then the equation of this line, I'm going to write it, go back to the original, is y plus x plus 5 equals 0. Okay, here's the definitions I said we were going to get to. The x-intercept is where the line crosses the x-axis. So where the line crosses the x-axis. And then inversely, the y-intercept, I bet you can predict, is where the line crosses the y-axis. And I'm going to point out one thing. If we're looking at any line that crosses the x-axis, so I've just highlighted in yellow an x-axis down here. If we look at what the y value is, if we're on that axis, it means we're not up and down at all. It means that our y value is going to be equal to 0. So when we're dealing with an x-intercept, the y coordinate is always going to be 0. And similarly, I'm going to highlight in pink over here the y-axis. So if we've got the y-axis here, and we look at it, any point on this axis here, or here, or here, or here, it's not moving side to side at all. So those ones for the y-intercept have an x-coordinate of 0. All right, so for these, they would like us to state the x and y intercepts of the following graphs. So that's a y-intercept. And this y-intercept is right there. And we've got a y-intercept, and it has an x value of 0 and then a y-coordinate of 1. For the x-intercept, it's right here. So for the x-intercept, our x-intercept is going to be x is 2, and in this case, y is 0. So for the next one, we've got our y-intercept. I'm just going to, I have the yellow highlighter, I'm highlighting all the y-intercepts. And I'm going to get purple, and there is none down in the bottom. Will come, and then this is sort of on top. Maybe I should have done it one at a time. Okay. We're going to have our y-intercept here. So our y-intercept is going to be not side to side at all. So x-coordinate 0, y-coordinate -4. And then for the x-intercept, our x-intercept is going to be x is 2, and our y-coordinate was 0. Okay, for this question here, they're trying to maybe fool us because it crosses the x-axis and the y-axis at the same point. So right here for this question, this is both the x-intercept and the y-intercept. It's both at the same time. So the x-intercept equals 0, 0, and the y-intercept also equals 0, 0. And for this last question here, it looks like we only have a y-intercept. It doesn't cross the x-axis at all. So for this one, our y-intercept equals, our x-coordinate is 0, and then we go up to 3. And then for our x-intercept, I'm going to write NA, that stands for not applicable. Not applicable. And the reason for this is because the line doesn't cross the x-axis. So if we're not given a graph and instead we're given an equation and we have to calculate the x-intercepts, we're going to use the fact that we learned before that to get an x-intercept, we're going to set y equal to 0, and then we're going to solve for x, or isolate x. And to get the y-intercept, we're going to set x equal to 0, and we're going to solve for y. So in these questions, they want us to find the x and y intercepts. We're going to do it 4 times, and then we're done. So we're going to find the x-intercept, and to find its x-intercept, we're going to set y equal to 0. We're definitely going to be doing that. And then to find the y-intercept, we're going to set our x to equal to 0 and solve for y. And I'm going to I know we're going to be doing this 4 times, so I'm going to copy and paste, and that'll just save a bit of time. So for 5a, we're going to find the x and the y-intercept. So x-intercept, I set y equal to 0. So y is going to be equal to 0. So I'd write 3x minus 4 times 0, because remember I set y equal to 0, equals 12. So 4 times 0 is just going to be 0, so it's like we can ignore it. So it basically means we have 3x just equals 12. And then we divide both sides by 3, and we're going to get that x equals 4 But we're finishing off by writing out the coordinates of our x-intercept. So our x-intercept is going to equal 4, 0 for this first one. So we're going to make sure that we write it as a point, and a point needs an x and a y. For the y-intercept, we're going to set x equal to 0. So that would be 3 times 0 minus 4y equals 12. Or minus 4y equals 12. Divide both sides by 3. Not 3, sorry. Divide both sides by minus 4. And we're going to get that y equals minus 3. So our y-intercept is going to be x was 0 and y is minus 3. And we've solved for our y-intercept. So we're just going to do this 3 more times. Y equals 0. So 2x minus 3 times 0 equals 6. That goes away. So we get 2x equals 6 or x equals 3, which gives us an x-intercept of 3, 0. For the y-intercept, we would put 2 times 0 minus 3y equals 6. 2 times 0 goes away. We have minus 3y equals 6. Divide both sides by minus 3, and we get y equals minus 2, or our y-intercept is 0, minus 2. I'm going to put those nice tidy boxes. For the doing it again, this time x-intercept y equals 0. So 0 equals 2x plus 16. I'm going to move the 16 to the other side. So it's minus 16 equals 2x. Now divide both sides by 2. And we get that minus 8 equals x. So our x-intercept is going to be minus 8, 0. For the next one, we set x equals to 0. So every single time when you're solving for x-intercept or y-intercept, I want you to write down that x equals 0 or y equals 0. It just reminds you of what you got to do. So for y-intercept, x equals 0. So y equals 2 times 0 plus 16. This goes away. Oh, that's handy. It just gives us y equals 16 straight up. So the y-intercept is going to be 0, 16. For the last ones, x-intercept, set y equal to 0. 0 equals x over 3 minus 5. I'm going to bring the minus 5 over to the other side. Oh, not there. The minus 5 over to the other side. So it becomes positive 5 equals x over 3. We want x by itself. It's being divided by 3. So we're going to multiply both sides by 3. Get rid of that fraction. So times 3 times 3. And we get that 15. 15 equals x. So our x-intercept is going to be 15, 0. And for the last one, y-intercept, so we set x equal to 0. So 0 over 3 minus 5. That goes away, and we're left with y equals minus 5. Our y-intercept is equal to 0, minus 5. And I'm putting them in some boxes. And that is it for lesson 6.1. Thanks for watching.